Thank you guys. You guys are awesome. So today we'll be going over chapter 1, the rest part of chapter 1. The rest of the part, the first concept we'll be talking about what is the measurement and their units, and then we'll be going over the temperature. We'll be talking about the different types of standard unit people have been using to measure something, and we're going to be finishing up by learning density and how to calculate that. So first thing, as I start my lecture always with asking questions. So I'll ask you, what is the measurement? Raise your hand. Anybody knows? What is the measurement? Anybody? Yeah, what is it?
The comparison of two physical.
The comparison of two physical units. What is the other option? Others? Yes.
Like the amount or like quantity.
Quantity. Getting, what is it? Give me a full sentence.
Like the amount or quantity or something. Or like
The amount of quantity that you have with something, right? Any other definition? The last table. Very last. What is it? How you define the measurement?
Like the amount of
Substance, right? That's true. So, measurement is assigning numerical value of a substance. For instance, you like to measure the length of a rod. You're trying to measure the volume of a spherical globe. You're trying to measure density of a solution. So you need to call, or you need to assign a specific units and standard measurement to count these physical properties of these substances. For instance, another example, if I say I am 5, does it mean anything to you? No? Until I say I am 5 feet. Am I 5 feet or what? I'm not 5 feet yet, by the way. So, until I say I'm 5 feet, you don't know what I'm talking about, right? I see sometimes people say that, I'm 20, but that means I'm 20 years old, right? What does it mean? But that's, people use that, but that's not the right way to call, I'm 20. It doesn't mean anything to me until you say you are 20 years old, right? Okay, so same way, there are two things. One is assigning measurement with a unit. So what is the unit we use? We use different types of units. For instance, centimeter, kilogram, meter, gram. A lot of them, scientists have standard measurement to see their physical property. So this numerical value is using for the physical property. Specifically, mostly people using by following this SI method. SI means C, right? What is Spanish in C means? Yes. I know some Spanish, right? Someone taught me 3 sentences. Who is that? Hola, gracias, gracias. Right? You, right? Okay. Okay, good. So C, I learned that 4th word when I was reading something. Anyway, so C. SI means System of International, right? As I said in the very first lecture, chemistry is a new language for you. You're going to be learning a lot of vocabulary to understand chemistry. So the vocabulary here is System of International. In US, in here, United States, we call SI as a metric system. So other than US, all over the world, people use SI, which we call again metric system. So in metric system have some base units, which is very interesting. the interesting thing in the base unit is, you see, it has some base unit for most of the measurement. So this numerical value we use for instance, M means meter, kilogram means kg. So S we call as a second, K for Kelvin, mol for mole, ampere, and candela, CD. Have you used candela?
No.
Sounds interesting, right? Candela. Anyway, so these are the ones we use for a metric system. So the book have a huge list of base and measurement units and their numerical values. They have a lot of a list of converting factors. So first thing in my class, I would like you guys to know these 7 basic units. What is basic unit for length, meter? What is the basic unit for mass, kilogram? I want you to know that. It's not that I'm asking you, hey, Dr. Haque, talking about to memorize chemistry. You said no memorization. Yes, I still saying no memorization. Did I? Your name is Megan. Did I memorize that? Hey, you Megan. Did I memorize that? No, I just remember that. You are Megan. I just learn how to recognize you as a David or Megan. So that's why you trying to recognize these 7 basic units. Okay? And these units could be converted in many different ways, and that's called dimensional analysis. In dimensional analysis will be 100 of meter. That meter is bigger, centimeter is smaller. So look at that, each one changing by 10-4. And when you see the prefix, then you need to recognize right away that this prefix apply for this converting factor, or you can convert with this convert from this prefix to that prefix for those base unit by using 10 factors. So let's see some example how it works. Okay. So for instance, if you have what is the base unit for meter? What is the base unit for the meter, for the length? I said that, right? Good for you. So, base unit for length is meter, right? So, meter, we write small m or capital M? Small m. And this small m means meter. What we learned from this table is 1 meter equal to 100 centimeter. If we talk about centimeter. You see, 10 to negative 2, what does it mean? It means 100, right? That means 1 centimeter equal to 10 to negative 2. So if you write 10 to negative 2, that means 1 centimeter equal to 10 to negative 2 meter. That's what it means, you see? Centimeter, 10 to negative 2. If you write other way, 1 meter equal to 100 centimeter. And but 1 centimeter equal to 100 meter, right? If I have, for instance, I have a picometer. That means 1 meter equal to 10 to 12 picometer. Picometer. That's how it works. And this converting factor we can use as a dimension. So you can use it as a different dimension, which is called unit factor. So 1 meter equal to 100 centimeter, what we can write, or if you write next one, 1 meter over 10 to 12 picometer. We also can flip it. If you flip it, that would be 10 to 12 picometer over 1 meter. That's how you convert from meter to picometer or picometer to meter based on what you need. And then how do you convert that? For instance, if it says that you're converting from, for instance, meter to picometer, so you use either this one or that one. Let me take this top part off so we can use this as an example when you convert from one unit to other unit. So step one, you're going to be using two steps. Step one, we'll be writing whatever unit is given, whatever value is given. Value comes with a unit. For instance, if you have it says you have a 10 meter length a desk. So you're writing with a 10 meter first. See? Write down given value with the units. Step two, you multiply with a factor. Take two steps to convert one unit to other unit. Any question? Okay, let's do some practice. So when you do practice, you see you follow whatever you have given, which is 325 milligram. 325 milligram, and you're converting to gram. Which one is basic unit of mass in here? Gram or milligram? Grams. So grams is basic unit, but you have milligram given. So that's what you're going to be starting off, because write down the given first, which is 325 milligram, right? That's what's given, step one. Going to step two, you need to know the converting factor. From where? From the table. This is the table that you know of, right? And from the table you see milligram to gram. 10 to milligram to gram is 10 to 3. So how do you write the factor? Factor would be so that means 1 gram equal to 1000 milligram. That's what it says, right? And now you can write the factor as a 1 gram over 1000 milligram. You see? Or also you can write as a 1000 milligram over 1 gram. You can flip it as needed. So which one are you going to be using? This option or flipped option? Look at that. You have a milligram. You should be set up such a way that this milligram gets cancelled out. So if we write this one, for instance, the next one, 1000 milligram over 1 gram. Can you cancel out milligram now?
No.
Because this is the top, this is the bottom. You cannot. So what you need to do? You need to write gram on the top, milligram on the bottom. So that is 1 gram, and which is over 1000 milligram, right? So then you can get the value. How you get the value? First cancel out the unit and get multiply the top numbers and then divide by the bottom number. Top is 325 times 1, and you dividing the bottom number, which is 1000. If you use a calculator, you can see you'll get 3.325 gram. Any question with it? Okay, I have a one problem. Now solve 355 milliliter to liter. $355 milliliter to liter. Remember, if anybody would like to solve in the board? Anybody like to volunteer in the board? You are welcome always.
Wait, how do we know the units to get from? Oh, that's
Here the units. You can follow this chart, guys. So spilling gas, let me see. Don't you just close it up? Close it up. Can you see? Close, right? We are going to continue the class. That one. Sorry, they just move on down there. Yeah, if you know. I'll let me open that one, okay? Then we're going to finish, and then we're going to go in the lab. So, 355 milliliter, 1000 still filling gas. Yes. Did you turn off? Did it turn off? Did it turn off the hose? Should be better. That's good. So, milliliter to liter. What is the converting factor you have? We have the factor in here. You see, the milliliter is 10 to negative 3. That means 1 milliliter. The table shows that 1 milliliter equal to 10 to negative 3 liter, right? And if you write other way, 1 liter equal to 1000 milliliter, right? That's what it is. Let me open that one. Are you feeling very strong?
That's just yes. It's like it's coming out.
Yeah, I'm feeling, now I'm feeling too.
That's from it. That's from
How can I
It's
hold
a
it on?
chair. Well, they don't have little breaks.
It's gonna move. Someone can sit in here, right? Sit and follow me. That's the only option I have. What's that? No, that's fine. Sorry. It's too light.
You can use my backpack.
Try it. Backpack might work.
Renee's backpack is big enough.
You guys are funny.
Wait, my backpack is really good.
Pero ya se quitó ya.
There you go, yeah. Okay, should be better, right? Little bit better? Okay, let's continue, okay? So, converting from milliliter to liter, so this is a converting factor, right, as you say. So, this converting factor we can use 1 liter over 1000 milliliter, and she used 1000 in the bottom because milliliter need to cancel out, right? Then you get the top 355, bottom 1000, what is 0.355. How many seed figure are you expecting for the answer? How many seed figure you have in the question? 3. So your answer would be 3. Then the question. You have 2 things in the answer, right? 1000, because this is also using to calculate 1 liter equal to 1000 milliliter. So in 1000, how many seed figure you have in here?
4.
How many seed figure? These have a 3, right? You said. How about the 1000? 1 seed figure. So 1 and 3 seed figure, the answer should be still 3. Why? Because this is a constant value. These converting factor, unit factors are not considerable for final seed figure, because this we don't count that, because this is a fixed number. Fixed number we don't take as a seed figure for the answer. Okay? So we don't take any converting factor figure. How about this one? 125 deciliter to milliliter. Look at the table. Look at the table that you are provided. Is there any converting factor from deciliter to milliliter? Yes, it is? No? So, okay, so figure it out. How can you convert from deciliter to DL to ml? Because DL2, you can come from DL to L, right? Okay, take some time, figure it out. So first of all, we need to convert from deciliter to liter, and then liter to milliliter. From deciliter to liter, what is the factor you have in here? You say deci equal to 10 to -1. That means 1 deciliter equal to, so that means we find 1 deciliter equal to 10 to -1 liter, right? That's what we know. And then, so if you write other way, 1 liter equal to 10 deciliter. So it's up to you which one you will be used. Again, dimensional analysis or unit conversion, you can use many different ways. It's up to you how you do that. For instance, you can use this one, you can use this one. If you use this one, the top one, there will be 1 deciliter over 10 to -1 liter, right? This is also, you can flip it. But if you use this one, there will be 1 liter over 10 deciliter, right? See? Actually, they both are same. It's up to you how you choose, which one you choose and how you convert it. Okay. And then deciliter to liter, then you convert liter to milliliter. Do you know liter to milliliter? Also given, right? Because milliliter equal to 10 to negative 3. That means that 1 milliliter equal to 10 to negative 3 liter. Or 1 liter equal to 10 to 3 milliliter, right? You see? It's up to you how you can use it. Okay, now we can solve it. When you try it, it's a 2 steps analysis. So, step 1, 125 deciliter, right? Step 1 is you write the value is given with unit, 125 deciliter, right? And then you use converting factor. The bottom would be the one on the top in the question given, which is deciliter. So deciliter you can use this one, or you can use that way. That means 1 liter equal to 10 deciliter, right? But we're not done yet, because here if we cancel out DL, I can get the value in liter. But question saying that convert to milliliter, right? Then you need to write another multiple with another numerical value, which is liter to milliliter. So let me ask you a question. Now liter on the top or bottom? Bottom. Because so 1 liter equal to unit cancel out exactly milliliter, right? The liter cancel out. So what you got in the top 125 milliliter over liter is bigger.